Yeah, so we have a bunch of questions and they kind of all fold into each other because all of this works together. And that's kind of what I'm going to talk about today. So these are the questions that we get most frequently, and they're really basic questions. And if you get a kind of a moderately deep understanding of these things, then everything else builds off that. It's much easier to understand more difficult concepts once you get these basic concepts down. But this is by far the biggest question that we get over and over every week. How do I aim my antenna? Okay, so there's no, trust me, there are no dumb questions. If you don't know, you ask a question, you learn, you build on from there. So this is the one, this is by far the number one question. This is way above number two, but this is the one I get all the time, we get all the time. So, so the first thing you have to ask, how do you aim your antennas? What do you want to cover? And a lot of times people say, well, if I cover everything, I'm covered. And it's like, no, that creates problems. You only want to cover, it would be wonderful if your antenna would only cover your wireless mics and zero else, right? But it doesn't do that. It covers an area. So the first thing you have to think about is what kind of an antenna you have. And this is pretty basic. They're basically, you have omnidirectional and directional antennas. And so an omnidirectional antenna covers from where it is in all directions horizontally, right? 360 degrees. When you move to your paddle antenna, or paddle type antennas, you're covering roughly 120 degrees. So you're covering 1/3 of that circle, and you're ignoring the other 2/3, which is a benefit to most people most times. But if you look up at, like, next time you go past a cell tower, you'll always see them in threes, right? They have 320-degree antennas, three directional antennas to go in three different directions, but they're not tied together exactly. They look in three directions separately. And then you have helical antennas, which usually are more narrow. And that's if I want to hit one spot on top of a hill or something, you would use that kind of an antenna. So this is kind of what those patterns in big general terms look like. If your antenna is that arrow in the middle, this is kind of how the coverage most often turns out, right? So an interesting thing is that peripheral vision is, for the general rule of thumb is it's about 120 degrees. So if you're using, obviously, if you're using an omni antenna, you don't point it anywhere. It doesn't matter, right? It's going everywhere horizontally, not up and down, but you usually don't have people 20 feet in the air and 20 feet below ground with wireless mics. They're flat on the stage or the deck or the ground or whatever. So most often we're using paddle type antennas, right? So basically the answer to this is, if you put your head on a wall, what you can see without turning your head is what you're going to cover with that antenna, right? So whatever your hall looks like. So this is probably what it looks like for most people. And this is fine, right? You put it somewhat centered in the back of the stage. And obviously this is covering above and below our room, but we don't care because we're only covering the inside and we got walls to block it. So you put it on the front of house position somewhere in the back of the auditorium. You point it at the stage, and now you're covering the stage and almost all of the audience, right? It's a little weaker in the back corners. This is kind of deceptive because antennas really don't have patterns when you get pretty close to them. It takes a little bit for that to develop. So the fact that you have, if I wanted to pick up those top and bottom corners in the back on the left-hand side, I actually probably am, because my antenna really doesn't have a pattern at that point, and I'm really close to the antenna, right? So I'm probably picking up those corners pretty much. Okay. But I can put it, in that corner. And in this case, because I'm a little farther away, I might have something that I want to exclude, right? So I used to have to work at a venue that was very much like this. It wasn't video in the corner, although, that's what a lot of people run into. So, for example, if you do business conferences, yeah, they probably got a platform with cameras on it and a bunch of video equipment, and that stuff is probably problematic for your wireless mic. So we want to avoid that. There's no sense picking that up. In my particular case, this room I used to work all the time had, it's where the power center was. All the three-phase electrical was coming in there, and there was a lot of power in that corner. And so I worked this way to try to avoid picking up as much interference from that electrical panel. It actually was behind a wall, but I mean, there's so much power that, it bled through. So I can put it in a corner. I can put it part way down the wall. I mean, if I put my head right there and I look at the stage, if I put my head flat on the wall, obviously I wouldn't be directly covering the stage. But I mean, this is very much like a cardioid microphone, right? You kind of point it at the singer. You got a bunch of singers on stage, but you got a kind of a wide pattern, and when you pull it back a little bit, it's going to cover your whole stage. So you always have to decide if all you want to cover is the stage, or do you also want to cover the audience? And sometimes if you do things like town hall meetings where maybe they pass a microphone out into the people in the audience to ask questions, a really good way to do that is have that microphone on its own system. You don't put that into the distro. You don't pick it up with your main antenna. You have something just for that, especially when you have digital microphones, because they have sort of automatic gain controls that they know about. And so that's a really good solution. If I have to have 8 microphones on stage and 1 microphone that I'm handing out in the audience to ask questions, I would prefer to have that 1 microphone all by itself. Don't have to, but that's a good way to do it. The other thing you can do is you may want to move the antenna closer to the stage. So in this case, if I was to move my antenna, maybe I've got lighting, maybe I've got a soffit up there or truss or something, and if I move my antenna closer to the stage, in this particular case, now I'm not picking up very much from behind me. So if I don't need the audience, I'm not picking up any interference or very little interference from their cell phones or whatever else they might have with them. And I'm getting a stronger signal at the same time. And we're going to talk about that a little more later on, because all these things are interconnected. So we're going to talk about how you tie all these things together, because each of these questions I'm going to go over by itself depends on the other questions that we're also going to discuss, right? So this is a building block. But when you move the antenna closer to the stage, obviously the signal is stronger because it doesn't have to travel as much distance. The signal gets weaker with distance, right? And also because now I'm picking up less noise. So this is improving my dynamic range, which is the secret to making all this stuff work, right? I can also put the antenna, if what I want to cover is the stage, I can put the antenna in the wings and shoot it across the stage. And that's going to do nicely. And you see, I've ignored most of the auditorium when I do it this way. So if that's what you want to cover, the problem that I always get is people call me and they go, well, my client wants to cover everything. It's like, no, they don't. They don't want to cover the men's room, I promise you. They probably don't want to cover the kitchen, but they say everything because they haven't really decided what they want to do. So they figure, well, if we cover everything, then I'm covered for anything I want to do. That's fine, but there's a penalty to that. There's a penalty for covering areas that I only need 1% of the time, because 99% of the time I'm going to pick up garbage from those areas, and that's going to work against me. So you always have to kind of really decide the more you can dial in exactly what you want to do, then the better we can dial it in for just that thing. If I have to do everything, I can. It's more expensive. So if you're working with a client that, I want you to cover everything in my whole building. Well, do you really? I can do that. It's going to cost a lot more. So if we can, lop off this area and this area and this area, I can bring the cost down. But if they want to cover everything, I can do that. Call me. I like that. We sell a lot of gear. More money for us. Okay. So now if we're talking about an Omni antenna, the Omni antennas radiate out, or radiate in rather, for wireless mics from a center point. So if I want to cover this room, I would put that antenna in the center of this room. That's generally difficult, If it's a church, you don't exactly want a mic stand up in the middle of the pews. You can mount it on the ceiling, and that's got some potential tiny issues. So this is what happens. So now if I do this, I've got everything. If I only want to pick up the stage, I would move that antenna closer to the stage. But as you can see, I'm still covering the hall. It's going to get weaker as I go back. So if I need to cover somebody out there, if you have a situation where you have a pastor that likes to run out through the hall, or a singer that jumps off the stage and wants to go in the back of the room, then you have to consider that. This is going to pick them up to a point where, again, your directional antenna at the back of the room pointing toward the stage would also do that, but it would very more likely pick up less RF noise and interference. That's what stops us. If there was no RF noise and interference, these wireless microphones would work for a million miles, but there is. So anyway, okay. So here we go. Right? What do we want to cover? Because it's easy to cover something once you define what that is. So almost always a directional antenna is going to be your first choice. For those of you that work in audio, I'll tell you I probably own 50 microphones, and I probably own 3 omnidirectional microphones, and they probably haven't come out of their boxes in years. It's the right tool for a certain job, but that job is pretty rare. So omnis, I tend to use omnis outdoors, because I can sort of centralize that. That's generally where I use them. Antennas, not microphones. But anyway, so just things to think about. But aiming the antenna is simply a matter of pointing the active part of the antenna at transmitters, right? So that's, like I said, if I've got a transmitter on stage and one at the back of the hall, then center mounting that Omni might work, or rear mounting that directional paddle type antenna would probably be my first choice. But that's kind of what happens with those. So another question that I get, and we got it 2 or 3 times as folks signed up, is mounting mic and IEM antennas together, because you have one antenna that's pitching and one antenna that's catching, right? One antenna is receiving from transmitters, and the inner monitor antenna is transmitting to receivers, right? So they're going in opposite directions, which another question I get is, okay, I'm only using 2 channels in my distro. Can I use the other 2 channels for my in-ear monitors? It's like, no, they're going the opposite directions. That'd be like, I've got a microphone plugged into my PA and it's coming out my speaker. Can I also sing into my speaker and have it come out my microphone? It's not going to work. They're different things. Okay, so normally, if you're using a helical antenna for transmitting for your IEMs, they tend to be narrow, and so that green one would be a little tighter. This diagram is considering that you are using 2 paddles, or in the case of RF venue antennas, a D architectural and a CP architectural antenna, and they be mounted on the same wall. Generally, it works best to mount these on the same wall. That's a big generality, but generally it does. And you want to separate them by about 6 feet, 6 to 10 feet. That way, the antennas don't magnetically couple to the other antenna. That's why we separate them. If you get them really close together, some generated magnetic field jumps into the other antenna and causes garbage that we don't want. Okay, so if you can, so if you have a more portable setup, for example, you have these antennas, on mic stands or something, moving the IEM antenna a little closer, a little farther up front from the receiving antenna avoids a little bit of that transmitting signal going directly into your receiving signal on the other side, right? It's not a big deal, but if you can do this, why throw it away, right? We don't want to waste anything that's free, because if we do, we're going to have to start paying big money for things that are expensive. So if you can move that transmitting antenna even a couple of feet forward towards the talent from your receiving antenna, from your wireless mic antenna, right? So we're moving our IEM antenna a little bit closer to the performers, and we're moving our wireless microphone antennas a little bit back from the performers. This is going to give you a very small advantage, but like I said, why waste it? So the only thing you can do wrong is to point one at the other. What you absolutely don't want to do is put one antenna on one wing and the other antenna on the other wing so that they're pointed at each other. If you think about this the same way you think about microphones and speakers and feedback, that's what's happening, right? If we point our microphone right at our speakers, we're going to get feedback a whole lot earlier than if we turn it around backwards, right? So probably everybody's experienced that. So we have the same kind of situation. You don't get feedback, but you get other garbage. So what we really want to avoid is pointing our transmitting antenna at our receiving antenna. Now, as always, with all these things, you can only do what you can do, right? And we'll get into why that matters or doesn't matter. I mean, sometimes it doesn't matter. There are occasions, you can stick a coat hanger in the back of your radio and make it work. Not very many, but it just depends what you're up against, which is another part of this that we're going to get into a little later. Okay. So the second question that I get all the time is how far is my antenna going to go? What's the range of my antenna? Now remember, antennas, let me back up. When we're talking about wireless microphones, antennas catch what you throw at them. They don't reach out for signal. They catch what you throw at them, right? So what happens is there's no limit to how far an antenna can pick up. I mean zero, not 0.000, I mean zero. There is no limit to how far an antenna can go. But what happens is it gets weaker with distance, right? Same way with a loudspeaker. The farther you get away from it, the quieter it gets, right? Now, a loudspeaker, I don't know if there's a limit to a loudspeaker. It's probably the same thing, but anyway, forget I said that. So anyway, there's no distance limit to your antenna itself, okay? What there is antennas get weaker with distance, and they follow inverse square law, right? So every time you double the distance, you lose 6 dB, right? So now, these numbers aren't real. These numbers are for illustration. So please don't think that any of this is real. This is kind of like all things wireless. Every time you set it up, it's a unique situation. You'll never get these numbers, but just to show you what happens. So if the microphone there is my transmitter, and let's say at a distance of 25 feet, because I can count 25s real easy, the signal that antenna picked up was minus 60 dBm. That's a pretty healthy signal for a wireless mic. But that's going to depend on, it depends on a bunch of other things. So that aren't part of this, but it depends how powerful your transmitter is and how much gain your antenna has. But let's say we have an antenna. This is the situation we have, right? So at 25 feet, if my signal is minus 60 dBm, if I double that distance to 50, I lose 6 dB. So my signal is now minus 66, right? And if I double it again, I'm out to 100 feet, I lose 12 dB, 18. You see, this gets quick, right? 30 dB is 1/1000th, right? So 56 to lose 6 dB is half, right? Or I'm sorry, we're talking power, a quarter. But anyway, this gets really big. This is like that, double a penny every day, and at the end of the month you have $2.5 million. This number grows really fast if I carry it out a few more times, but obviously it's like this isn't going to happen in the real world. It's going to be so weak. But there will always be signal in your antenna. It'll be so infinitesimally small, but we're picking up, Voyager 1 from 30 billion miles the other side of Pluto. We can still pick up that 1975 radio being run on solar cells, and I doubt there's much solar 30 billion miles the other side of Pluto. Anyway, NASA can pick it up. If you have a $50 million receiver, you can do it. If you have a $50 million receiver, step right up. Anyway, so this is what's going to happen, right? The farther our antenna is, the weaker the signal gets. Now, don't panic. I mean, 100 feet's not a long way for a wireless mic. 200 feet is not a terribly long way for a wireless mic. We can still deal with this, right? But the distance that works, we only care about, like I said, the signal never drops, but the signal we can work with is the place at which your signal drops below 20 dB above the noise floor, right? So that's why I put forget it all the way out there at the end. I mean, you don't see noise floors, much lower than the 90s. Almost anywhere on the planet, down in a cave, in a Faraday cage, but generally speaking, your noise floors are going to be in that kind of level. So I kind of came up with this idea. Pardon my bad graphics, but so if the water in these glasses is the noise floor, and we stick that graph down in there, you can see if the noise floor is very low, we have much more distance available. If the noise floor is very high, we have much shorter distance. That's always pretty much out of your control. The noise floor tends to be what it is. There's some little things we can do about it, but this is television stations. This is computer chips. This is video monitors. This is 5G low-band cell phones. It's from everything. It's from everything that's passing electricity is generating RF, but those are tiny amounts. But anyway, whatever your noise floor is, so if we look on the right, that's the noise floor in the middle of Times Square. And if we look all the way on the left, that's the noise floor on top of a mountain in Idaho. Probably. I don't know. Making this up. But just to illustrate the point. So you're going to stick that ruler in your glass full of water, and it's going to tell you if the level of the water happens to be 20 dB above the noise, right? So that's not just noise floor, that's noise plus the cushion that we need, the extra dynamic range that we need to reliably lock up our transmitter to our receiver to get capture effect, right? So the more noise you have, the more noise floor you have, the shorter the distance that your antenna is going to seem to work. But it's not just the antenna, it's all these other things together. All right. So the third question that I get all the time is what's the number I can use with your antenna? And it's like, it depends. It depends on a bunch of other things, right? So what we want to do when we look at coax is, these are mostly the kinds of wire that you're going to see, coax wire that you're going to see. So the old RG58, and this is at about 500 megahertz, and I did have to slightly guess here because for some reason, all the wire manufacturers, they give you a rating at 700 megahertz, which if you happen to be in Europe right now, that's great. That's a good number for you. But here in the US, we're working mostly in the 500s. And then they give you one for 400. So the amount of loss increases with frequency, right? So lower frequencies, you won't have, if you're that top one that I say minus 14, if you're all the way down to 470, that might be minus 13.5. If you're all the way up to 608, it might be minus 14.2. I don't know. If you're that close, you're in trouble. Okay, so plain old RG58 cable, the cable we've used forever. That's the coax. It's about the diameter of a pencil. Has 14 dB of loss in 100 feet, more or less, depending on frequency. At RF Venue, we make a cable called RG8X, as do some other people. Ours has some extra advantages that other brands don't. So RG8X, when you just see that on a wire, it doesn't necessarily mean exactly the same thing. But the loss is about 7 dB in 100 feet. In other words, it's half of what it was in RG58. So if you could run RG58 successfully to 50 feet, and again, I'm making up numbers, this is going to change in every venue, but let's say it was good to 50 feet, in that same venue, RG8X would be good to 100 feet, because it only loses half as much signal, right? And then when you get into the big wires, I usually recommend a Belden wire called 9913. It's sometimes called LMR 400 from a different manufacturer. Again, I cut the loss in half. So if I could successfully run 100 feet of RG8X in a venue, I could move my antenna another 100 feet and be in the same place, right? We following this? So how far you can, first of all, it depends on the cable you're using, right? So whatever you want to use, there's dozens and dozens of other cables, but this pretty much covers everything, I think. Look up the manufacturer's spec, and you're probably going to see a loss at 400 megahertz and a loss at 700. And again, you got to work in the 500s, so you kind of got to pick the middle of that. Again, I'm not worried about a quarter of a dB or half a dB or a dB here or there, because if you're down to a 1 dB difference, your toes are already probably too close to the edge of the cliff. So anyway, so we want to look up the spec for whatever wire that we want to use and see how much loss there is with distance. The less loss, the better. All right? Which is fine. If you want to use 9913 Belden at 25 feet, that's great. It's stiff, heavy, expensive wire. It's probably not necessary. It's probably necessary somewhere, but in general terms, you probably don't need that level of performance. But we'll get to figure out how you do or not. Okay, so we got all these numbers. We got the loss in our antenna distance. We got the gain of our antennas. We got the transmitting power of our microphones. We got the loss in our cable and some other things. Do you really want to do the math on all that stuff? And the answer is I usually don't. So if you come to our website, at the top of every page kind of looks like this. You can see there's a button in the toolbar that says Performance Tools. And if you click on this, it's going to take you to a page that looks like this. And on this page, you're going to have to answer some questions. They're just drop-down boxes, right? So you don't, like the distance, mic to antenna, it says 25, 50, 75, 100. I don't care if it's 28.5 feet. Again, we're cutting it way too close. So you just click on all these boxes. You tell us what microphone you're using, the distance that you are away with your transmitter to the antenna, what antenna you have, what type of coax cable you have, how far you're going to run that cable from the antenna back to your distro or your receiver, if you've added bandpass filters, what distro you're using. And then it gets down to the bottom here where it says noise floor measurement available. If you have a scanner, and that's a great way to make this even better, if you have a scanner and you can measure your noise floor, you tell that box yes, and then on the bottom box, you enter that value. So this is all, this builds what we call a link budget. Now you can do a bunch of math to figure all this stuff out if you really care about decimal points, but this is an easy way for you to figure out what's going to go with what and if it's going to work when I get there, right? So I'm putting in a noise floor of minus 85. That's a moderately noisy common noise floor. I expect your noise floor probably going to be better than this, but if it isn't, this is it. So obviously if your noise floor is lower than this, then you can go even farther with this, right? But you have to measure that and put it in. Okay, so at the bottom of this, there simply is a button that says calculate. I forget what it says. You push the button to make it go, and you're going to get a red, yellow, or a green light. If you get that green light, that's going to tell you that you have 20 dB of signal above that 85 degree noise floor. And so that is going to work. What this doesn't tell you, so just so you don't get this wrong, this doesn't tell you that you're going to be able to operate 24 microphones or 64 microphones in that space. That is going to be up to another problem, and that's, frequency allocation. What channels are you going to pick? So this is only going to tell you that one radio will do that. Actually, right next to that performance tool, when you click on that, we have another program that'll tell you where your microphones need to be tuned to make this work as good as it can be. Again, it's not a guarantee. It's as good as it can be in that spot. Okay, and so that's kind of how you get to knowing how all these things interact. So what we're trying to say here is, if you build this foundation, these are the things. Everything else grows out of these things, right? So if you deeply understand, that's what we're trying to get here. These are beginning questions, but if you really understand these 3 points, then everything else is a much simpler thing to build off of these. But this is the foundation. If you get the foundation right, you can build the other things. If you don't have a foundation and you ask more complicated questions, I don't know. I mean, I have to build if you call me, and you're welcome to call me anytime, and you have a more complicated question, I will have to revert this all the way down. I need to know these things before I can build a more complicated answer, right? So you got to know these things. This is a free program. When you go to our website, you don't have to download anything, which means you can look at this on a tablet or a phone or a computer or a laptop, anything you want. You don't have to register. We don't collect your email. I don't need to know your mother's maiden name or your social security number. Just use these, okay? Because this is a great way, before you leave your shop, office, or wherever, to know when you get to your venue if this stuff's going to work, right? If you're selling wireless microphones from the West Coast to the Middle America, you're not going to get in a car and drive there, probably. So you'd want to know that this stuff's going to work when you take it out of the box. And this is just the simplest way to get a very, very, very good answer. About the only time this isn't going to work is if you're trying to install this stuff on a military air base, right? Because they got crazy stuff. Or if you're maybe around, super crazy industrial machinery, you're in the middle of a Tesla factory, or you're in the middle of a hospital around X-ray machine. Like, how many times have you done that? There are people that do that, but almost nobody. So if you're just talking about a church or an auditorium or a nightclub or a school, and the military air base isn't across the street, this thing is going to work really, really, really well for you. It's really going to simplify everything and tell you all the things you need to know. So with that, that kind of concludes my presentation. I think we've got some other questions, Adam, that again, are going to kind of build on from this, but this, you got to have these basics down. So what do you got, sir?
Yes, absolutely, Don. So you guys submitted a lot of great questions. Of course, we don't have time to answer everyone. Hopefully, the presentation addressed most of them, but we picked some good ones for you. And also, Richard has been answering a lot of your questions on the session. So let's kick it off here. So the first one is, how can I get the most out of a little?
Well, there's an easy answer to that. Don't give anything away, right? Don't utilize all the best practices that you can. In other words, sure, everybody's got a budget, and that's fine. But what we want to do, if we're working with any budget, a small budget or a large budget, we don't want to give anything away, right? We don't want to point the antenna in the wrong direction. We don't want to use the wrong coax wire. There's a good one. So we used to, like everything I used for 30 years was RG58 probably. You don't want to save $10 a cable using RG58. I don't want to, that loss that I'm going to get, I can't ever get back without spending a lot of money. So I don't want to give that away. I want to use the frequency coordination. I want my channels to be good. I don't want to give that away. Can you? Yeah, you can pick the wrong channels, but now you're going to have to buy more expensive radios, and it's going to cost more money. So what you want to do, unfortunately, I can't tell you how to do 64 microphones for $500. It's not going to work. It's going to take everything's going to take what it's going to take, right? But we want to keep that as low as we can. So we want to be smart. We want to employ all the best practices. That's why we do these. And we have a YouTube channel where you can go back. If you're new to this, you can go back and see all the ones we've done over the years. They're all separated by topics. You probably know a lot of these topics already, but there might be some that you don't really know about or quite understand. I would say go back there and learn they're all about best practices, right? That's what we're trying to teach, how to do it the best way, the most efficient, economical way you can do it. Sometimes that's inexpensive, sometimes that's expensive, but it's the best way. So that's what I would say about that. Or you can buy lotto tickets and hope you win the lottery.
That's cheating.
Let me know if that works.
Axient, here we come. All right, so signal loss with receive antennas when using 75 ohm coax.
Yeah, so there's something that's kind of misunderstood a lot, unfortunately. So first of all, I think all the microphone manufacturers, their equipment is set to be at 50 ohm. Now, it's not exactly 50. That's the nominal value that they give for it. So the first thing I would say is, they all tell you to use 50. Why would you want to use something else? Okay, here's why. Because when you go look, so this is probably going to boil down to 50 ohm coax versus 75 ohm coax. And you can go look online and you can say, gee, if I use 75, I get less loss at 75 feet. Going back to those loss charts, that's for those 50 ohm cables. There are 75 ohm versions of those exact cables, and you would see less loss. You go, well, that looks good. Why wouldn't I do that? The problem is impedance mismatch. So the quick, easy, simple answer is you get echoes in the wire, okay? So if the source and the load impedances don't match, in the case of 75 ohm versus 50 ohm, right? A portion of the signal that's equal to the magnitude of the impedance difference, right? The difference between those is reflected at the point of impedance changes, right? So those reflections mix with your incident signal, your intended signal, and they produce voltages and waveforms in the transmission line. right? So remember, we're talking about, when we talk about 50 ohm and 75 ohm, we're not talking about the resistance of the wire. We're talking about the transmission lines, okay? And so you get less, you get echoes. It's like, it'd be like trying to listen to a PA system in a basketball gym. I can make it loud, but I can't understand it because I got too many echoes. So that's sort of the simple answer to that. I mean, there's some complicated math about, what voltage occurs at the nodes and the antinodes and all. We can figure all that stuff out, but I don't think about it. Just use 50 ohm cable. Now, stuck in a situation where that's the only cable I have and I have a show in 20 minutes, I'm going to use it. Okay? It, depending on things, might work fine, but it's not the right thing. Okay? The other thing is, and you got to look really carefully, because you may have to look at this for 5 minutes to see the difference. But 75 ohm BNC connectors are not the same size as 50 ohm BNC connectors. And sticking the two of them together where the pin goes in, the diameter, it's not always, but it may be different. And you may actually damage the BNC connectors. So if we're talking about more than just 75 ohm coax by itself, if you're going to buy 75 ohm coax and put your own 50 ohm BNC connectors on it, then that won't be a problem, but that's not what you're going to do. You're going to buy pre-made cables. Just don't. Back to that getting your money's worth. Just don't. It's just not the right thing, right? So that's what I would tell you about that. Yeah, I get that all the time. People tell me about using RG6 or RG59. Yeah, we're going to do that. It's like, guys, that's not wireless mic antenna wire. That's TV wire. So your TV antennas are 75 ohm, almost all of them, and your wireless mics and your wireless in-ear monitors. I would say all, but there's always something. I have never seen a wireless mic or an IEM that wasn't 50 ohm. So if it exists out there, it's invisible to me. So that's what I'd tell you.
I have seen some 75 ohm designs, but they're very off-brand, seldom heard of.
Well, they might be used for, some other kind of communication devices, or I don't know, Shure and Sennheiser and Electrosonic and sound devices and Audio Technica, the people that make wireless microphones, they don't use that.
Right.
So, there could be somebody building something in a garage, I guess, but I've
Yeah,
never.
exactly. So like
Just
you
use
like to say,
just use 50. Shut up and use 50. It's the right
yeah,
thing.
it's
There
another
you
one of those, don't create the problem if you don't have to.
go.
And
Yeah,
keep
yeah.
your 75 ohm cables for video and word clock. Okay,
Yep.
so all right, cool. So the next question, using the same pack, why do some physical bodies have strong RF signal and the others cause a heavy reduction in signal?
So let's talk about that for a minute. So we talked body pack, but let's also talk about handhelds and body pack. So the problem is bags of salty water. Radios don't like to go through water, right? So when you have a handheld microphone, you're holding it in your hand, and yes, your body is still surrounding it, but it's really only the size of your hand that weighs what, a pound or two or three? I don't know what a pound weighs. So you have a pound or two or three of salty water around your radio. When I put a belt pack on my hip, I have my whole body kind of there. And what you're going to find, so right away, the belt pack to handheld is, 6 or 8 dB difference in signal power, right? What they're able to transmit. So if you've noticed that, at our church, wow, the handhelds all work better than the belt packs. Yes, they do, because that's just how it works. Because the water, your body, when you put a belt pack on, absorbs a lot of that signal. And the bigger you are, the more it absorbs. So if you put a belt pack on somebody that weighs 300 pounds and you put a belt pack on somebody that weighs 95 pounds, you're going to get a stronger signal on the 95-pound person. Can't do anything about that. That's just the way it works. Yeah, water, and radio waves aren't friends. So that's why we try to keep it away. Which is why. So let me add. Which is why you never want to put a belt pack transmitter in your pocket, right? So now that little whip antenna that's hanging out of it is only the distance of the thickness of the cloth of my pocket away from my skin. And remember, inverse square. So what is that? A hundredth of I don't even know what it is. It's a very tiny distance, right? If I put that belt pack on my belt and that antenna is now hanging a half an inch away from my body, inverse square, the power, doubles every time. So that is a huge improvement. It doesn't seem like much. A half an inch, how much difference could that make? A lot. Don't put these things in your pockets, especially if you got a cell phone in your pocket. And that's not what he asked, but good luck getting people to turn off their cell phones because you have to use a gun to do that anymore. But certainly don't let them be on the same side of your body. Yeah, that's what I can tell you about that.
Cool. Last question we have here. I have 2 sets of antennas for a large inside space and now need temporary antennas to cover an outside space, question mark.
Well, the correct is not the right word. The best practice way to do that would be to use something like our 4-zone antenna combiner, right? So you can put 4 pairs of antennas into that and you can adjust them so the first part of your question there, whoever sent it, leaves me with a question. I'm assuming you're using 2 pairs in the same room. Unless your auditorium holds 3,000 people, that's probably not a good idea. At 1,000 people, you're probably, almost always better off using 1 pair of antennas. Here's what you want to avoid. You want your transmitter to find 1 and only 1 pair of antennas, right? That's usually not possible unless your antennas are in separate buildings and separated by some distance, right? So if I've got 3 buildings on a campus and they're antennas in separate rooms, I'm getting some isolation. What we're talking about is crosstalk, right? We would like the crosstalk to be 0. Well, it's never going to be 0. There's always going to be some. So there's a ratio, At 50-50, boy, you're in trouble. If my transmitter's equally hitting 2 antennas, that sends confusing information to your receiver. It's going, which one do I work with? So the better you can make that ratio at 80-20, you're probably fine. And everything in between is going to depend on where you are and a million other things. But we'd like that to be, we'd like that separation, that ratio to be, as far apart as possible, right? So that's why you generally don't want to use multiple antennas in the same room. In really big rooms you can, because again, with distance, like we saw, that's why those things are so basic. We saw that level decreases with distance, And so in really big rooms, you can do stuff like that, like in a convention center or something. Okay, so the 4-zone combiner adds the ability for you to adjust the relative levels of each of the antennas. In other words, if I have, let's say, 2 classrooms, let's just talk about 2, and I have antennas in classroom 1 and antennas in classroom 2. If my wireless mic is working in classroom 1, I don't want to see classroom 2, right? So what I want to do is I want to turn down my antennas in each classroom to only service what I need. So in other words, in classroom 1, so I'm going to take my microphone transmitter and then I'm going to get as far away from my antenna as I could ever be or would ever want to be, right? And I'm going to attenuate those antennas until I knock it off the air, and then I'm going to bring them back up 4 or 5 dB, right? So I'm going to make that antenna purposely weak. Wow, that sounds like a bad idea. Nope. I don't ever want my antenna to go any farther than it needs to pick up what it needs to. If my antenna would work at 1,000 feet, let's say, and I only need to pick up at 100 feet, I'm picking up 900 extra feet of noise. I don't want that. So I'm gonna attenuate my antennas in classroom number one, and then I'm gonna go over to classroom number two, and I'm gonna attenuate the antenna in classroom two, so that when I'm in classroom two, my chances of picking up the antennas in classroom one are greatly reduced, right? Because I've attenuated that antenna. I want to say I make it weaker. That just sounds like a bad thing. Well, what do you mean you want to make it weaker? What do you mean? And that's what I mean. I don't want that antenna to pick up anything it doesn't have to. So that's kind of what we do. So that's what we're going to do. So you've got, now, if you're talking in your particular case, 3 sets of antennas, I'm going to bring them in. My outdoor antennas aren't going to mix with my indoor antennas probably very much, unless they happen to be, back to back. I mean, one walls block what they block. It depends what your wall's made out of. It mostly depends. Oh, here we go. Back to the why water bags block frequencies. It depends an awful lot on the moisture content of your wall. If your walls don't have a lot of steel in them, a lot of metal in them, right? So things like, you don't think about it, but bricks and cinder blocks and concrete all have water in them. Wood has water in it. And the more water it has, the more it blocks. So, I mean, yeah, bricks are not dry. I thought that was crazy. I've been reading recently that they think maybe the water on Earth came from meteors. I'm going, it came from rocks? How much water could there be in a rock? I got this block of granite. How much water is it? There's water in it. It's tiny. Anyway, sorry. Going off on a tangent. I just thought that was cool that I've been reading that in science magazines lately. Sorry.
Hey,
Bird
that's
walk
great.
sideways.
It's very fascinating, Don. We appreciate the introspective there because it makes you think, right?
Well, so kind of any question you ask about this is probably related to 6 or 10 or 100 other factors, right? We're not just looking at one thing. So the question you've always got to ask yourself is, if I make this one thing better, what do I make worse? And can I live with making that worse, right? We're always trying to pick things that make what we want more desirable, and give away the things that we don't care about. So same with this. It's the same as you do that with every question that you answer all day long. What am I going to have for lunch? You ask that. Well, if I eat the extra sandwich, maybe I won't eat the fries and get fat. I don't know. It's a trade-off. It's always a trade-off. There's never just a right answer. It's always a trade-off. What am I getting? What am I giving up? So, wow, I really went sideways. Sorry.
It's all right, Don. This is a great session. Thank you. That was really well done. I think this is definitely one of our greatest webinars because we see so many questions. Feel free to reach out to any of us. You can reach us all at info@rfnu.com, or you can send us a contact form. I'll send that link for you guys. Of course, we love all of your questions. When you submit them to our webinars, keep them coming. It gives us more topics and more ways to help you, right? So that's the idea. Thank you, Richard, for answering all those questions in the lightning round here. Certainly, sometimes we like to call them out. So maybe next time, feel free to answer some of those live, Richard. I definitely implore you to do that. But are there any final words from you guys on the most asked questions this year? All
No?
right.
Yeah.
Well, let me ask the applications engineers, what is the biggest question you answered this year for customers and users? What was the most common question that you got?
Mine was how to get more zones working.
Interesting. Zones. All right. And Bob?
Well, I would say probably related to dropouts in uncoordinated frequencies. Because they didn't bother to coordinate their frequencies for 6 channels or so, and they get dropouts because of that. Maybe they conflict with a TV station or something. So that's probably what I see. maybe not the most often, but fairly commonly.
Yeah,
It seems to be the number one thing in wireless, right? Open channels and
well,
interference.
so let me just add one more thing because there's some confusion. There's two parts to making a wireless, basically two parts to making a wireless mic system or bunch of mics work, okay? So at RF venue, we deal with the antenna part. We get the signal from point A to point B so that you can use the signal. That's half the battle. The other half of the battle we really can't control, and that's that you have to put your microphone on a frequency that's going to work, that doesn't have too much noise at that frequency. And that's the other half of this. So both of these things have to work together. We make antenna products, so we're moving electromagnetic waves from outer space, That's what we do. Once we get it there, if you don't set it to the right frequency, you're going to get a dropout. So if you don't get enough signal there, you'd get a dropout. That part we can solve for you. Once we get it there, we have to get it to a good channel so that it doesn't drop out. So when people call and say, I'm getting dropouts, the first thing I have to do is establish that their antenna system is working properly. That's the first thing. And the second thing is it set to channels? So a real easy one, actually this would be my fourth one, but it doesn't really apply to us, except that we want to help you make your radios work, right? So it's like, hey, I just bought your DFIN and your distro 4, and I'm still getting dropouts. Okay, is it dropping out on all of your 5 microphones, or just some of them? Well, just some of them. Well, so that pretty well tells me the electronics are working. The reason it's not working on 2 of your channels, but working on your other 3, is that you have bad channels. You have bad frequency coordination. And that's the part you got to work on. So there isn't anything I can sell you that will set your frequency coordination. Although we've got some tools to help you find that. But that's a separate problem. So those 2 things have to work hand in hand. Right? So the fact that you're still getting a dropout doesn't mean the antenna's bad, because it's working on some of your mics or some of your ears. I bought a combine 8, and 6 of them are working good and 2 of them aren't. You've got to change your frequencies. You've got to get a frequency coordination. So that's the other half of this that is really outside of what we make and sell. Although we're happy to help you try to figure it out. Call me. I don't care. If it's you buy it from somebody else, things we don't make, you have to, because we don't make them. But we got to make all this stuff work together. So that's kind of why we're here. We don't want to make it all work together.
Awesome, guys. Well, I just shared the RF Venue Spectrum Tools product listing page, as well as our wireless system builder for those asking about our tools.
There you go.
So definitely check that out. And from working at RF Venue, I see the number one thing for me is finding that open channel. Once that is done, we can easily get you a working wireless system with our product line. So thank you all for your time. Thank you, Don. Thank you, Richard. Thank you, Bob. This is a great session. I'll be posting this to YouTube as soon as I can. And definitely check us out on the next webinar next year. So thank you again for a great year with our venue. And we'll be looking forward to seeing you soon. Thanks, guys.
Right, guys.
Happy holidays, everyone.
Take care.
Bye.
Bye.